For oxidation reduction, major part of your exam, I think it's going to be an emphasis this year, maybe along with a little electrochemistry. I would expect that to be on the AP exam, as well as your embedded exam, which will be scheduled out this week. I'll let you know when that is as well. So electrochemical reaction, remember I'm going to cover as much as I can so you get the best base that you can, because you never know what's going to be on the test. Not really know what the other class is doing at all right now. Anybody know? Alright, I have no idea. I'm just trying to get as much covered as I can. So understand what I'm doing, get as many topics as I can, get you the questions assigned that you can so you have an idea in case you see it. Alright, I can't, we're 10 days now. We've missed 10 days, so that's a lot. Electrochemical reaction. We have to look at the flow of electrons. This should be an easy process. You watched a little thing last class. A redox, an oxidation reduction, a reaction in which at least one atom changes in oxidation states. All right, so if one changes, most likely another one's going to change, but you only need one to change, and it is a redox. You only need one to change, and it's a redox. So a reduction is any process in which the oxidation number of an atom decreases. All right. I know the guy was talking fast last class, but this should make a little bit of sense. Take a look. I'm going from +4 to +2. Which number is bigger? 4. I went from 4 to 2. So it's being reduced. All right. What actually happens at that point? What do we have? Are we gaining electrons? Yes. All right. So we are gaining electrons. All right, oxidation, I went from 0 to +1. What happened to the number? It got bigger, and we're doing what with electrons? Electrons. Any process with oxidation increase becomes more positive. We are losing electrons. And you have two ways that you can do that: oil rig or Leo goes Gur. Leo's go Gur. That's my favorite. All right. Oxidation number, the charge of an atom we would have if the compound in which it were found were ionic. So let's take a look. Let me do a couple to see if we can do this. All right. So if you have a periodic table not memorized in your head, if you have one that's available and you can pull that out, that'd be great. Let's see. All right. 3, 2, okay. So if we had these 5 random compounds that I just selected by myself, oh, let me add 2 more. Let me add Ca and O2. Okay. How would I go about figuring out what the oxidation numbers of these 2 species are? Yes.
Well, there's like some rules that are always usually applied. Like for SO4, you just
yes.
For SO4, oxygen is always -2 unless it's in a peroxide.
Okay, so oxygen's always a -2 if it's unless it's in a peroxide, not in a peroxide here. That means it would be O2. So what is the overall charge of oxygen? -8. This compound has what overall charge?
0.
Has a 0. So what does the charge of sulfur have to be?
8.
Oh my gosh, you guys are good. All right, now if I do this, SO4 2-. What is oxygen always? -2. All right, so I have -2 times 4 equals -8. My overall charge is -2, so I have sulfur plus -8 equals -2. What does sulfur have to be? I know my students know this. I used to do this all. I used to hound them on it. Okay. What about NaCl? This is a tough one. Here we go. NaCl. What do you got? +1, -1. What about O2? O2? 0. What about carbon dioxide? +4, -2 times 2 is -4. All right? Slow me down. Yep.
If you were to ask for the oxidation number of oxygen and CO2,
-2.
Okay.
-2. I know, that's a good question, because that's how they ask them on AP. What's the oxidation number of? If it asks for the total oxidation number, then you can multiply, but they won't do that. All right. To help remember oxidation and reduction, oil rig, oxidation is lost, reduction is gain. That's the one you wanted me to do because you're all so happy about that last class. Oxidation is lost, reduction is gain. Cheryl, what is it gaining? What is it losing or gaining? Electrons. Very good. Electrons. All right. Electrons. All right. So reduction is lost. Oxidation is lost. Reduction is gain. All right. So let's take a look. Type of redox reactions. You have corrosion, a type of redox in which a metal is destroyed.
Sorry about that.
Metathesis reaction, a reaction in which atoms are interchanged, and there is no change in oxidation number. Disproportionation reaction, a reaction in which a single reactant undergoes both oxidation and reduction. Here is an example of disproportionation. We have bromide. We put it in a liquid with hydroxide in it, some type of basic solution, and we get bromine and we get BrO3. All right. What is BrO3? What is it? It is not bromate. It does not have a charge. Bromine trioxide. It does not have a charge. If it had a charge, it'd be bromate. All right, you got your halogen polyatomic rule. What's your halogen polyatomic rule? Halogen polyatomic rule. Anybody? Halogen polyatomic rule. Anybody have anybody? I know you've heard it. I know you have. I know you have. I know you have heard it before. What's a halogen? What group? Group 7. All right, so any group 7 element, any group 7 with 3 oxygens will have, well, we'll have -1, 18. All right, so that means BrO3 minus is bromate. What is ClO3 minus? Chlorate. What is IO3 minus? Iodate only on the weekends, just like Van Brockenberger. What's that? Maybe she doesn't date on the weekends. Sorry, she doesn't have a social life. She just does her chemistry homework, which is what you're supposed to be doing on the weekends. All right. So, a redox reaction in which a metal is destroyed. All right. The halogen polyatomic. All right. Don't confuse the following causes. Don't forget the following definitions. Oxidizing agent causes oxidation, undergoes reduction. It gains electrons. The reducing agent causes reduction, undergoes oxidation. All right, so if I went back up to the top and I wanted to label these with oxidizing or reducing agents, how could I label these with oxidizing or reducing agents? What's this? All right, what is this one? All right, Easy? Easy, lemon, easy. All right, so it's also, yes?
Clarify. So when it's going down, it's oxidizing. When it's going up, it's glycerin.
As far as the agent is concerned, or just the actual process?
No. As far as the
Okay, so if it is being reduced, the number's getting smaller, it is the oxidizing agent. It's causing oxidizing to occur on the other species, because what is it doing? It's giving it, what does it get? What are we doing when we go from +4 to +2? What are we doing? We're gaining electrons, so what's going to happen here? What are we doing?
It's gain. It's gain.
This is gaining electrons.
Whatever's happening to it, it's doing the opposite. So if that's being reduced, then it's the oxidizing agent.
Right, it's the opposite of what it's doing.
Whatever's happening to it is
Whatever's happening to it, the opposite is
what it's doing.
It's what it's doing to the other thing. Okay? So these two, if you know it goes from +4 to +2, it's the oxidizing agent while it's undergoing reduction. If it's undergoing oxidation, it's the reducing agent for the other one. All right, you need to know good oxidizing agents and good reducing agents. They will be asked part 2 or possibly in a multiple choice type question. So I did list those out for you. Atoms, ions, and molecules with large electron affinities, fluorine and chlorine, compounds with large electronegativity, large oxidation states. Y would be a B, C, D, E, F question on part 2. The electronegativity increases as oxidation state increases. Electronegativity is the tendency of an atom to draw electrons towards itself. 2 examples of good oxidizing agents are permanganate and chromate. Which one's permanganate? Which one's chromate? MnO4 minus is permanganate and chromate is CrO4 2 minus. All right. Good reducing agents, any active metals, silver, magnesium, aluminum, zinc. We don't use francium or any of those guys because they would blow up the entire reaction. Any metal hydride, sodium hydride, calcium hydride. Hydrogen can act as either an oxidizing or reducing agent. That is some very important points there. I want to add those in. Okay. Before we balance a redox, let's first refresh your memory how to calculate oxidation numbers. All right, so the oxidation number is the number of charge of an atom would have if a compound were found to be ionic. The rules are the sum of the oxidation numbers must equal the overall charge. All right. To assign oxidation numbers of a metal ion not listed on the table, start with the overall charge. If we're MnO4, then you start with 8 for a total of +7 for manganese. Continue to all other species listed are considered. Subtract if it is a positive value. We just went over that. It's not anything that you should. All right, neutral substance containing only one single element, 0. Nitrogen, helium, oxygen, bromine, chlorine, iodine, hydrogen. Any monoatomic ions, same as the charge. Example, sodium B +1. What's calcium?
+2.
All right, what is aluminum? +3. What's strontium? +2. I'll add a check. That's okay. All right, any hydrogen combined with a non-metal? +1. Hydrogen combined with a metal is -1. Metals in group 1A, 2A, oxygen, halogens. All right. Any issues there? You should be able to pull that right off the periodic table. There shouldn't be anything you don't know. All right. Let's balance redox equations using the oxidation number method. Basic solution is demonstrated. So you will be told if it's a basic or if it is a acidic solution, and then from there it'll be different because you're going to be adding hydrogen ions or OH ions to one side or another. So See if you can talk with the person next to you and figure out what are the reduction and oxidation pairs. Talk with the person next to you and see if you can figure out what the pairs are that are being reduced or oxidized. Nixon needs to talk. Sean and Van Brockenberger can talk. Try not to look at the bottom yet. Try to do it without looking at the bottom.
Do you split up like hydroxide?
No.
You just leave it as X minus 4.
Well, no. You look at hydrogen and oxygen oxidation numbers, see if they change.